Okay, this worksheet is just got some word problems that we're going to go through, and these word problems, we're going to set up our system of equations, which means we need to come up with two equations to have a system, and then we're going to solve that system, and we're going to solve that system using substitution. So this is actually worksheet 4.2, number 3, that's attached on your remote site. Okay, so the first thing, and probably the hardest part, is going to be, can I come up with these two equations? Okay, so as you read through the information, okay, it says that Richard and Tio have a combined age of 31. So how would we represent that? Now we can stick with X and Y, or we can change the variables to sometimes make more sense to us. So since Richard starts, I'll use R for Richard, and I'll use a T for Tio. Okay, so if they have a combined age of 31, that means if I add their ages together, I get 31. So I'm going to say R plus T equals 31. That's one equation for my system, is just R plus T equals 31. The second sentence is going to give me my second equation. It says Richard is 4 years older than twice Tio's age. And a lot of times we get confused by where to put the variables and stuff, but look for the word is or was, a past tense of is. Here's the word is. And a lot of times in math, is means equals. So when it says Richard is, I'm going to say Richard equals 4 years older. Older means to be plus 4. 4 years older than twice Tio. Twice means to take 2 times. So I'm going to say 2t plus 4. So my second equation is R equals 2t plus 4. In order to solve these, you have to have two equations. So make sure you get that. I have two equations. Now I'm going to apply my substitution, system to this system of equations so that I can solve it. Which variable is by itself? Okay, if you look at this 2t plus 4 is the part that is by itself. So I'm going to substitute this into the top equation for the r. So I'm going to say 2t plus 4 plus t equals 31. Now if you'll notice, t might not have been the best choice of variables to use because t and a plus sign look a lot alike. So you got to keep track of things here. This is a 2t, okay, and there's another t. So I'm going to get a total of 3t plus 4 equals 31. If I subtract 4 from both sides, I'm going to have 3t equals 27. And if I divide by 3, t equals 9. Okay, I have to go back and figure out, T stands for Tio's age, so I have to go back and figure out Richard as well. So I'm going to plug it into this bottom equation and say Richard equals 2 times Tio, well T is equal to 9, plus 4. 2 times 9 would be 18, plus 4, Richard would be 22 years old. So we have R is 22 and T is 9. So I want to put this in the context of my story problem, so I don't want to stop there. And I need a little bit more room, so I'm going to erase this. But I'm going to say Richard, 22, Tio is 9. And you go back and you ask yourself, does that answer the question? Are Richard and Tio, if I combine their age, would I get 31? So if you add those together, would you get 31? The answer is yes. And then, is Richard 4 years older than twice Tio? Well, if I double Tio, take twice his age and add 4, do I get Richard's? Yes. So those are the two correct ages. Okay? Second one, it says a community theater sold a total of 400 full-price tickets for adults and children. The price was $8 per adult ticket, $5 per children's ticket. If the total revenue was $2,750, how many adult tickets and how many children's tickets were sold? Okay? Well, it says we sold a total of 400 tickets. Some of them were to adults and some of them were to children. So I'm going to say the adult tickets plus the children's tickets equals 400. That's referring to how many tickets I sold. The number of tickets from adults plus the number of tickets of children equals 400 total tickets sold. Now the other information that they gave us deals with the revenue or the cost and the amount of money brought in. Okay, so an adult ticket was $8, and if I sell 8 of them, to get the total amount of money from this, I would have to take 8 times A plus children's tickets were $5 a piece. So I'm going to take 5 times C, and that's going to give me the total dollar amount. So one of my equations is just about how many tickets were sold. The other equation deals with the amount of money that's brought in. Okay, now, if you look at this system, we don't have A or C by itself in order to substitute. So you're going to have to do that yourself. You can get either A or C. I'll get A by itself. I'm going to do that by subtracting C from both sides of the equation. So I would have A equals 400 minus C. And now I'm ready to take that and substitute that into the bottom of the equation. So I'm going to say 8. Instead of A, I'm going to substitute what A is, which is 400 minus C plus 5C equals 2,750. And I'm going to let you solve that from there. You're going to solve this. You're going to get a value for C, your children's tickets. And then when you get an answer, you're going to plug it in to figure out how many adult tickets you sold. And then always go back and check your answer. Okay? This is not an easy worksheet. Coming up with some of these equations takes a lot of practice. Just wrestle through it, persevere, and give it your best shot. Okay? Join the Zoom if you have questions.